Chemical engineering themed Sudoku. Sudoku puzzling is one of my favorite hobbies, and, in my opinion, one of the best and most fun ways to boost your problem-solving skills. But I'm not talking about the Sudoku puzzles you'll see in the newspaper, which are computer-generated and partially filled with some numbers already. I like the kind of puzzles that have other kind of clues that force the solver to make logical deductions. I wanted to introduce my chemical engineering students to this type of Sudoku puzzle, so I set one myself and I themed it around a common piece of chemical engineering process equipment, the partial condenser. In this video, I am going to show you how to solve it. Let's start with a brief rundown of the rules. They are, normal 6x6 Sudoku rules apply. And just in case you're totally unfamiliar with Sudoku, that means place the digits from 1 to 6 into every row, column, and box, once each. Additionally, there is a partial condenser in the middle of the grid that has a dashed outline. Digits inside of it must sum to exactly 8. There are also two lines, a blue input line to the partial condenser and an orange output line. The digits on these lines must sum to the same total, and this is my way of incorporating a mass balance into the puzzle. And finally, digits in the gray shaded circles are odd, and digits in the gray shaded squares are even. Before I start the solve, I want to encourage you to pause the video, and if you haven't done so already, give this puzzle a try by clicking the link in the description box below. These puzzles are so much more fun to solve by yourself. Okay, so let's get started. And just like a chemical engineering problem, it's perfectly normal to spend a couple of seconds or minutes by thinking about how or where to best get started. Something easy I can immediately do is to pencil mark the circles and the squares. Because the rules state that they have to contain odd and even digits respectively, this reduces the number of candidates in those cells by half already. However, that's the only thing we could say about these cells for now. So maybe I'll move on to the partial condenser, which includes 4 digits that sum to 8. Unfortunately, there are a variety of ways to do this. For example, 1124 or 1223. However, I can note that the maximum size of a digit inside the partial condenser is a 4. Because a 5 would require the other 3 digits in the condenser to all be 1, and that would necessarily break the Sudoku rules. Unfortunately, this is a dead end as well. With no numbers in the grid, I'm left to think about the blue and the orange lines, which I admit at the beginning seems a little daunting. There are 5 digits on the blue line and 8 digits on the orange line, and all I know is that the sums are equal, which seems hopeless. What progress can we make with that knowledge? Oftentimes, in chemical engineering problems, you can gain some insight by considering the limiting cases and understanding that the correct solution lies somewhere in between these extremes. So, let's apply that principle here by thinking about the minimum and the maximum sum for each line, especially in conjunction with Sudoku rules. These 4 digits on the blue line are all in the same 2x3 box, and must therefore be different. So, the minimum I could make them would be 1, 2, 3, and 4. There's one other blue line cell poking into the box below, and that could be a repeated 1. The sum of 1, 1, 2, 3, and 4 is 11. The maximum the blue line could be would be 3, 4, 5, and 6 inside the box with a 6 outside. The sum of those digits is 24. On the other side, the orange line is arguably even easier. 6 of the digits on this line are within the same box, and Sudoku rules tells us that it has to be 1 through 6, which sums to 21. There are 2 other additional cells outside this box, which are also in the same column. At minimum, they are 1 and 2, and at maximum, they are 5 and 6. Totaling the entire line gives us a range from 24 to 32. And this is the key to breaking into this puzzle. Realizing that the absolute maximum for the blue line is equal to the absolute minimum for the orange line, and thus this is what must be true. Now we have a good start. This is called a 1-2 pair in column 6. It means that one of the cells is a 1 and one of the cells is a 2. Of course, I don't know which one is which yet, but it does mean that none of the other cells in column 6 can be a 1 or 2. Therefore, I can pencil mark 3, 4, 5, and 6. Over in box 2, I have a 1-2 pair as well. Now I can use this 1-2 pair to eliminate 1 and 2 from the rest of row 4, and that means 3, 4, 5, and 6 are in the other cells, and therefore I have a 1-2 pair again. Recall earlier that I deduced that 5 and 6 could not go inside the partial condenser, and now I have 2 cells that are a minimum of 3. Therefore it's forced. There must be 3s here and 1s there. Now it's time to do some Sudoku and tidy up the pencil marks. Now I have a 1 and a 3 looking at this cell, which means that it must be a 5. Now this cell can't be a 5, and remember from the 1-2 pair earlier that it also can't be a 1, therefore it's 3. More Sudoku now. This 2 is looking at that gray square, meaning it can't be a 2, and there's also a 6 in the box, therefore it's 4. Same thing over for this gray cell. It's seen by a 2 and a 6, and therefore it's a 4. This new 4 eliminates 4 from the rest of its column, and therefore in box 2 the only place for a 4 is there. Now this 4 eliminates 4 from the rest of row 2, that 4 eliminates this cell, and there's a 4 in one of these two cells, and that means 4 is placed in box 1. Switching over to 2's, neither of these two cells can be a 2 because there's a 2 right below it. Therefore 2 is placed in box 2 there, and that disambiguates the 1-2 pair. The last two cells in box 2 are a 1 and a 6, and that 1-6 pair makes this cell a 5. New 4-6 pair here makes that cell a 5, and now column 5 is almost filled. It's only missing a 3. 6 is now placed in box 6 by Sudoku, and that leaves behind a 2. 2 cells left to fill in row 5, and 3 looks there, therefore this is 3, and now in row 5 we need a 5. Now we finish off box 5 by putting in a 1 and a 2. Finish column 3 with a 6, which leaves a 1 and a 6 in box 2. Only one place for 1 in box 1. And finish off row 1 with a 2. Finish box 1 with a 3 and a 5. Tidy up the remaining pencil marks, and that is the puzzle solved. The key lesson here is that problems may seem overwhelming at first, but if you start with what you know and focused in the correct place, it becomes more manageable. It also gets much easier with practice. For more Sudoku puzzles that are like mine, only much better and oftentimes more difficult, I highly recommend the Cracking the Cryptic YouTube channel, where you can watch 2 Sudoku experts solve puzzles live on camera. I promise you, it's much more entertaining than it sounds.